In today's lesson, we're going to talk about the place value of whole numbers. Now, our number system is based on the number 10, and there are many different theories as to why that is. But one of the commonly agreed upon reasons is the fact that we have 10 fingers and 10 toes. Now, if any digit is moved one place to the left, its value increases 10 times. So I start with 1, I move it one digit to the left, and it becomes a 10. Similarly, if I take the 1 that is in this 10 and I move it one spot to the left, then I'm going to end up with 100. Notice that zeros are added as placeholders, and we learned all about placeholders, zeros as a placeholder in Introduction to Whole Numbers. And so I can just keep continuing on. I move this this one digit to the left, and I get 1,000. I'll move this one digit to the left and get 10,000. I will move this one digit to the left and get 100,000. And finally, I will move this one digit to the left and get 1 million. All right, now notice that when each value is multiplied by 10, you will get the value of the number below it. So 1 times 10 is 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. And 100,000 times 10 is 1 million. And again, we could keep on going up. Now let's think about this in terms of blocks. These unit blocks that we have, you can think of them like Lego or dice, but each block represents a unit in our place value system. Now once you get 10 unit blocks, they can no longer stay here. They must move here to the tens position. Similarly, when you get 10 groups of 10, so this is one group of 10, when you get 10 groups of 10, they can no longer stay here. They must move over here so that you have one group of 100. And you would work this the same way as you keep moving up into the thousands, 10,000s, etc. Now, a place value chart allows us to easily find the place value of any number that we might want to know. So you can see here we start with the ones, and they have the units, the tens, the hundreds. Then we get up into the thousands, so we have thousands, 10,000s, 100,000s. And then we get up into the millions, so we have millions, tens of millions, hundreds of millions. Note that we've only gone up to 1 million, but you could keep adding on as necessary to have billions, trillions, and so on. A place value chart also helps us to read a number in words, and it allows us to write a number in expanded form. Now you're thinking, what is expanded form? Well, if you think about the numbers, when it's written in the way that we normally see it, we call that standard form. So numbers like 4, 8,730, 56, and notice that commas, you will see those often in numbers that are bigger than hundreds once you get into the thousands. Then commas are used to separate the digits in groups of 3. Now, when a number is broken down by its place value, then we have what's called expanded notation. So let's write 56 in expanded notation. So we're going to start with our place value chart. Now 56 is a small number, but we're going to get larger. And what we do is we start with the most right digit of the number, and we place it in the most right box and go from right to left until all of our digits have their own box. So here we've done that. We placed the 6 and then the 5, and that's all we have. So when we look at the 5, we have 5 groups of 10. So that's 5 times 10, which tells us we have 50. And then, of course, we have the 6 units. And so in expanded notation, 56 is 50 plus 6. All right, so that was pretty simple. So let's go ahead and this number is read as 56. But let's go ahead and look at a number that is a little more interesting, 5,673. So we want to write this in expanded notation. Again, I'm going to use this place value chart. And I'm going to start with the most right digit, place it in the most right box, work from right to left until every digit has its own box. All right, so we've done that here. And so we're going to start with this 5, which is in the thousands under the units. So that tells us we have 5 times 1,000, which is equal to 5,000. We have the 6, which is in the hundreds, so that tells us we have 6 times 100, which is 600. Then we have 7, which is in the tens, so that's 7 times 10, which is equal to 70. And then finally, we have 3 units. So the expanded notation is 5,000 plus 600 plus 70 plus 3. And we read that as 5,673. Now, this is an even larger number, but again, it does not matter the size of the number. We always follow the same procedures. So this is one of those ones that follows the same rules. So we take the most right digit, place it in the most right box, and go from right to left until all of the digits have their own box. So we've done that here. Each digit has its own box. And now we can go ahead and write the expanded notation. Start with the 3, which is in the billions. So we have 3 times a billion, which gives us 3 billion. Then we have the 9, which is in the hundreds of millions. And that's 9 times 100 million. Then we have the 4, which is in the tens of millions. So we have 4 times 10 million, which is 40 million. Then we have the 7, and that's 7 times 1 million, which is equal to 7 million. The 6, which is here under the thousands, it's in the hundreds of thousands. So 6 times 100,000 gives us 600,000. And this 8 is in the tens of thousands, so that's 8 times 10,000, which is 80,000. And then we have a 1 here, which is in the units of the thousands, so that's 1 times 1,000, which gives us 1,000. Almost done. We have the 5, which is in the hundreds, so it's 5 times 100, or 500. We have the 3, which is in the tens, which is 3 times 10, which gives us 30. And then last but not least, we have 2 at the end. So this number is read 3,947,681,532. And that is a very large number, but again, we follow the same procedure, same set of rules. And that is your lesson on place value of whole numbers.